and welcome to the Age of AI podcast. On the show, we talk to entrepreneurs and innovators all over the planet who are using machine learning to transform their industries. And we mean real-world applications, tangible business value, not just research projects. This podcast is produced by Sandcraft Transnational, which is a global education company helping non-technical entrepreneurs and executives become technically fluent. Thank you and hope you enjoy the episode.
Hello everyone, I'm your host Aman, CEO of Sandcraft Transnational, and I have with me today a new very special guest, Christoffer Holmgård. Is that right?
That's exactly right. Thank you.
And Christoffer is the founder and CEO of Modl AI, which is a software company that uses machine learning to transform how video games are being developed, which is really exciting because I've been fascinated by the business and the economics of game development for a while. And I'm so glad that we'll finally get to sit down and chat about how the industry is changing and what's really going on. So thank you so much, Christoffer, for joining us.
Aman, thank you so much for having me. And it's exciting to be here today and to be able to contribute to the podcast.
Appreciate it. So yeah, like before we get into the technical stuff and what your company does, to set the context, let's talk about the game development industry for a little while, right? So who are your customers and what's their situation? What's going on?
Yeah, so the games industry is a wide and varied and interesting place. And you'll often see sort of like new business models spring up, new genres. It's a business that's in an industry that is in constant evolution.
Hmm.
However, if you sort of like look across the industry, once companies sort of like mature a bit, there's a part of the industry that is typically defined as sort of like the mid-tier part of the industry and up.
Hmm.
And those are the game companies that we typically serve and work
Hmm.
with. We're happy to work with smaller studios as well, and we do that sometimes. But the bulk of our customers are, these mid-tier game development studios that maybe they have a few titles out that are in production. They have a number of years sort of like under their belts as well. They've started to have like specialized functions sort of across the game studio, and they have well-defined and operating processes. So that could be, I would say, but at the lower tier, that could be a studio with maybe 30 to 50 people, and then that could go, just up from there, up to hundreds of people working together in the same constellation.
So you said the industry from a it's like the big fat game studios and then the mid tier and then the smaller game studios and then the indie developers, right? It's like that. Those are the four layers of the industry, and so that's one way to categorize it. When you talk about games themselves, right? How do you categorize and like form groups of different types of games? Like is it like online, or is it like online versus things that you just get and you play without being connected to the internet, or is it like multiplayer, single player? How do you categorize games for your purpose, for your specific purposes?
Actually, one thing that's maybe worth saying just before we go there
Yeah.
is that, even when you're a small indie studio, one of the things that characterizes the games industry is that if you end up having a hit game, you can quickly, jump to a different part of the industry, and suddenly your company might need to scale very quickly. I think we've seen a couple of notable instances of that recently. There's a title out that came out some months ago called Valheim. And it's all about being, it's an indie game, small team that made it. It's all about being in this like Viking, spirit world, and you're fighting monsters made by, I don't know, a tiny team, 7 people or whatever, right? But
Okay.
you launch the game and suddenly you have 4 or 5 million players in the game.
Wow.
And now you're in a totally different situation, right? That's one of the things that's interesting about an industry that is so hit driven as the games industry. You can switch category as a company very quickly if you hit the zeitgeist with a great product. So that's one aside there. If you then look at sort of like how the industry is organized, I mean, from our perspective, obviously we talked about going from, via studio sizes. That's one way of thinking about the industry. For us as, a machine learning product and service provider, we mostly think about it in terms of what kind of game are you making? So
Yeah.
what is your game genre?
Yeah.
And then we think about like, how does it get to the consumer? Those two things are important for us. How does it get to the player?
Mhm.
And so we divide it sort of like along those 2 lines. Important for us is you have sort of the casual games, which are like the mobile games that are typically consumed in small amounts of time. They're typically sort of like puzzle oriented, very sort of like approachable and welcoming, and they grow more complex over time.
Yeah.
And then you have sort of like the action games or the role playing games, things like that. that are more, they require a greater time investment, and perhaps also you need to build up some dexterity, some manual skill in order to play them in many cases.
Hmm.
But on the other hand, the play sessions are kind of like longer, and your engagement with the game tends to be sort of like deeper in a way.
Hmm.
And those are the two parts of the industry that we focus on at the moment as Model AI. Alongside that, you have other genres of games. Of course, you have like there are narrative games and strategy games and all these kinds of things. But yeah, from a genre perspective, and the reason we think about it that way is that that's really a determinant of what kind of AI is appropriate and
Hmm.
useful in different ways.
And so the theme seems to be that you focus on online games, right? Which have large multiplayer games in a way, to be more specific. And you focus on games that are also, whether they're casual or role playing games. That's how you differentiate.
Yeah. Casual is one category, and then the online multiplayer games, role playing game or not,
Yeah.
that's sort of like the other bucket that we work with at the moment. And the common denominator for both of these kinds of games is that they are, like you're saying, they're online games.
Hmm.
When we look at both the casual games and the online multiplayer games,
Yeah.
to my mind, they're all online games essentially, because even if you're not playing against other people in real time, all the casual mobile games are continuously receiving updates from their teams via the internet that then eventually makes it to their players, right?
Hmm.
So what characterizes both these kinds of games is that one way or the other, they are games that are delivered as a service in a sense,
Hmm.
because like once you have the game out, you're either hosting a world or you're bringing out new content continuously to your players, or you're doing both essentially.
I see. And so, how does the development vary between the different types of games that we talked about just now?
So if you look over at the casual space and the mobile space, you'll typically see very frequent releases of new content.
Hmm.
So in that part of the industry, you bring out new content of the game, maybe even new rules, new versions are coming out. Maybe every 2 weeks, maybe
Hmm.
every 4 weeks. You're bringing out total content packages. Over in the sort of like the larger game space, where it's like these larger action online games, it's more of a seasonal thing. So you'll see multiple months typically passing between major content updates and drops. So they sort of like work at different cadences, even though, in both spaces, you need to bring out new content continuously to stay relevant. I think if you look at one title that people might be familiar with in the casual space is a game like Candy Crush, where you'll see new level packages come out every month. And over in the action space, you could think about a game like Fortnite, for instance, where they come up with new parts of new maps, new characters you can play, or even completely different game modes come out, sort of like on a seasonal basis, right? And I
Hmm.
think those are like the two archetypes in the two categories that you might think about.
I see. I see what you mean. And so the economics for you know these two sides is completely different as well, right? Although on one side, for casual games, you are pushing new releases a lot. So let me make this just a more general question. How does the economics vary from a player standpoint? And like, okay, I have this casual game which cost me like maybe two people to develop, and we they basically monetize through ads or something like that, and then they have new releases coming out a lot, right? So it's like a factory that's churning out new games more and more and more and relying on ad revenue, versus you have a slightly more serious game, whatever you call it, right? A more involved game where you have more resources in development, more resources taken to for each release, but so it's more seasonal, and then you monetize through other ways. Like you can't fund a big tough game with ad revenue, right? The economics just doesn't work, right? So how does it vary?
Yeah. I guess what you're saying about the casual space is absolutely right. Some of the revenue will come from ads. That's a typical pattern. You might also charge people for in-app purchases. So, for instance, for more lives or other kinds of currency that you can
I
use
see.
inside of the mobile app.
Yeah.
So both of those things sort of like drive it over there. But I think for the casual games, what's probably characteristic there is that you can pivot more quickly because a lot of your testing happens inside of in the market. You put
Mm,
something out there, you A/B test it up against a certain region or whatever.
interesting.
If we're looking at the action games, the bigger the game gets, the less feasible that becomes because you have a bigger upfront investment,
Mm,
and you need to hype it more when you bring it out as well,
yeah.
right? And features take longer, and content takes longer.
Mhm.
So over in that part of the industry, you typically see that when you're developing the content, you're doing a lot of the assessment and evaluation of the market fit internally, perhaps. and
Hmm.
maybe you have like a trusted group of players that can give you feedback, but a lot of it happens on the inside. And because you have that bigger upfront investment, you then typically also ask your players either to pay for the game, like in order to get access to it, at first, or you charge them for different kinds of like cosmetic upgrades and other things like that inside of the game later. So you still have the in-app purchase aspect over there.
And so let's now talk about what the problems are that game development studios faced, given the context that we've just discussed, and how you come into the picture.
Absolutely. Absolutely. Yeah, thanks. So one of the reasons that we started Model AI was that what we do in the company is essentially based on some of the frustrations that we've experienced ourselves while developing games,
Hmm.
and some of the sort of like general trends that we can see across the game industry that we've also been subject to as game developers before. So the fundamental economics of game development is that at the outset, especially if you don't have a huge marketing budget, the likelihood of bringing out a game that does a significant profit for you, that sort of like doesn't just break even and enable you to build the next game,
Yeah.
is maybe 10%, right? So that means like 1 in 10 games will bring back like a significant profit for the people who made them. Some will
Yeah.
break even, some will lose money, right?
Hmm.
So game development is inherently like a super risky business. So that's one part of it. So anything that you can do in order to de-risk sort of like part of the investment and become more certain that your game is going to perform in the market,
Yeah.
it's hugely valuable to game developers, right?
Hmm.
Now, so that's the first problem. That's while you're making the game. You're
Yeah.
sort of like hoping you're doing everything you can to make sure that you have this sort of like hit success in the market.
Yeah.
But now, if you actually make it there, now you have a different problem because you're now in the market and you have had a successful game. You're probably running it as a games as a service, and you,
Hmm.
in many ways, you didn't just like ship a product that's now done. You have essentially opened a successful store on the internet, right? And
Mm.
now you need to scale
Interesting.
your production apparatus needs to keep up with that,
Hmm.
because now you have this fan base, all these players, and you need to service them, support them, and bring out new content. So and as you go toward this, like as I said before, there was a small likelihood of this becoming a hit. So
Yeah.
you probably haven't invested in the infrastructure to support all that scaling, all that growth, because you knew it was only going to happen with 10% likelihood, right?
Mm.
So how do you manage and how do you cope with that part of the process? And that's essentially where we are coming in as a provider in Model AI, and that's in general where we think machine learning and AI has a lot to offer, because the more you can automate these processes, both while you're building the game and while you're maintaining it and upgrading it in the market, the more you can sort of like de-risk this, and the faster you can scale once you eventually have that hit production.
I see. So, in summary, if I understand correctly, for a casual game or for any game, while you're building the game, you want to make sure that you de-risk the market adoption, or
Mhm.
you basically keep your costs down and everything, so that you don't get much of a hit. Right? It's pretty simple. You want to reduce your cost, and then once you have the game out in the market, then instead of about it being keeping your costs down, it shifts into how do we provide more value to the gamers who are adopting the game, so that we keep the hit running, like people don't so you keep retention of the gamers, keep them interested by adding more levels or more products within the game or more other stuff, more fun, and keep growing the community, because you only have one hit once in a while, right? And a hit game, you haven't invested too much money into building out that entire infrastructure to support a huge community, and now you suddenly have the problem of too much demand, which is a good problem.
That's exactly right. That's the problem in a nutshell, right? The key thing, and I think that's a mantra across any game genre, right? Is that quality is king, in the sense that eventually, if players don't see the quality, if they don't get what they're looking for, they're going to leave. You can market it as much as you want, right? And if you have a continuous payment model, you just need to keep the quality up, because otherwise you don't get retention. And if you're scaling your development process very rapidly, or you're trying to get quickly to market with the game, either way, right?
Mhm.
It can be a real challenge to keep quality up, and that really is a differentiating factor for games.
Okay, just for the reference, what percentage of games, and you probably don't we don't probably won't have any data on this, but in general, like what percentage of games are things that people buy, like I buy the game and I play it, versus I get the game for free, the Doom model. Like I get the game for free and then I pay for in-app purchases as we go along.
I don't have any hard
Yeah,
data on hand right
yeah,
now, but
yeah.
I can tell you like everything in mobile is leaning toward the play first, pay later. That's the predominant model there, and that's more than 50% of the industry's revenue at this point. And we're seeing the same movement happen for a lot of the games over on the PC market as well. Where like you'd probably say console games are more of like holdouts, like they're following the classic model that you pay upfront for the title and then you can play it.
And for the console games, I assume it's more like they still have in-app purchases afterwards, right? But the retentions probably look different because somebody's bought the game and then they're gonna play it because they bought it, right? Versus if it's a free game that you can play later, it heavily depends on retention as a business model.
Absolutely, that's correct. But even for the ones where you pay up front, you would still find some amount of in-app purchases or other like upgrades or seasonal passes and things like that. So it's not an either or. And if you
Yeah.
look at sort of like the real money indexed cost of purchasing a video game as a consumer, there's one of the most well known game developers in the industry, Raf Koster. If you go and read his blog and watch his talks about it, he has some great content about this. But you can basically see that the cost of buying any video game in terms of like both per megabyte or per experience or whatever, it's never been lower, and the trend is moving towards zero.
Wow.
So the cost of onboarding onto a video game, if everything continues, it'll on average it will be zero eventually across all games, right? So that's where the industry is headed, and so you recoup the revenue through retention later.
Yeah, so the future is in retention. Like you cannot charge enough for a game to break even on the cost, even if you have a sizable. I mean, yeah, it's just not gonna happen, right? Unless you have a really huge game like God of War, or something like that.
Yeah, and I think those tentpole titles they will still be able to generate revenue that way for many years, and there's also something in having knowing that you can pay once and you'll never have to pay again. I don't think that model is going away anytime soon. I'm always cautious with analogies to the movie industry, right? But
Mm,
but it's kind of like buying a movie ticket. It's a one-off. Now you have the experience. That's what you get, right? And
yeah.
on the other hand, you have like Netflix, right? And now Netflix is getting into gaming, so this is getting very confusing. But on the other hand, you sort of like you pay as you go in order to access the content that you want, right?
Makes sense. Cool. So, how do you use machine learning? What products do you offer, and how do they fit into this picture?
Mhm, mhm. Yeah. So what we do in Model is that we sort of our basic mission is as we phrase it, we're looking to revolutionize the way game development pipelines work,
Okay.
and for that to happen, we're building what we're terming an AI engine. And that's very high level. Essentially, what we do is that we automate things that human workers, human laborers would normally do as a part of the game development process.
Okay.
Because the thing that doesn't get talked about so much is that even though the games industry has seen a ton of growth and we're putting out all of this content, it's actually a growth that has been largely attained by adding more people to productions, by scaling up the number of staff, by outsourcing to other countries. And then you have other people doing it for you there, right? And that's why the game industry has been operating and driving this growth for a long time. And we don't consider that 100% sustainable because from one perspective games are getting bigger and bigger, so there's just like a limit to like how much you can
Yeah.
continue this process, right?
Yeah.
And it's not good for the people in the industry either necessarily. Look at a lot of the stories that come out about overworked video game developers and testers that are being paid nothing and all these things. These very real issues here in the games industry that can be addressed, right? And we think that a lot of this manual labor can actually be taken away by automation if we put an AI engine like what we're building into the mix here. So what we do is that we start with quality assurance. That's the first place where you can use our AI and machine learning products.
Okay.
We can essentially deliver bots that you put into your game from they basically play the game from the perspective of a player,
Mm-hmm.
and they will sweep through your game and use machine learning on the fly. They don't even need to train on the game, but on the fly they'll make sure that they cover all the game content and they make sure that it works. And normally you would have a human do this. So you would have a human running into all the walls, opening all the doors, clicking all the buttons, right? And so that's the first entry point for us where we say, let's make that an automatic process, get the AI to do it, and the person who used to do that can go and do something else in the game production.
Mm-hmm.
Then on top of that, make it a continuous process. Because most game studios, whenever you're working on a game, a new version of the game is produced every night automatically by your build. It's called a build system.
Yeah.
So it's like every night there's a one fresh off the build system, right? So why not just integrate the AI into that process, and we will automatically test your game every night for all the bugs that we can find.
Hmm.
That's what we're working toward. And then on the other side of that, we are putting in, when you work with us, and if you decide to use our QA tools, or if you want to get the AI engine not for QA but for other purposes, we put hooks into your game so we can see everything that's happening inside of the game. We can pull telemetry and actions from inside of the game.
Mm,
Essentially, see what human behavior is going on in there. And so once we get that data, we have the basis for training bots that not just explore the game, but bots and AI agents that actually copy the behavior that we've already seen in the game. So that
I
gives you
see.
sort of like more human like evaluation and everything. And eventually, for some titles, we take that all the way, and we use that behavior to create AIs that you can actually play against inside of the game if you're doing a multiplayer game. It's all really like a spectrum and a continuum for
Yeah.
us that sits from from let's explore and see if the game works to let's play the game together with the human players.
Mhm. First, let me summarize what you just said. For any people listening to this. Okay, so your mission is to revolutionize the game development pipeline and the different stages of game development. Some of those stages, which are like the long tail, which are really manual labor, like testing games and clicking every single thing, and doing basically every single thing that the game has to find glitches and bugs. That's one thing. And then the other is programming those AI agents, or not programming those AI agents properly so that they to keep the game interesting and challenging. And the former, the quality assurance, is something that can be hugely automated by using your machine learning bots, right? So they play the game for you, and then they and of course, since it's a computer, it can really try out every single thing that a human possibly cannot, right? So I can clearly see the value there. How much of the cost of a game typically is spent on QA?
Yeah, it's a good question, and it's really hard to find industry data, and of
Yeah,
course it varies across game genre, right?
absolutely.
But we go by a rule of thumb that says
Yeah.
like 10 to 20% of the development budget, depending on how you define QA.
10 to 20%. And then when you talk about building agents for in-game stuff, is that more of a like value add once you've already in the customer with a QA process, or is that where's the bulk of the value that is unlocked by machine learning?
Yeah, I think it's both places actually. So I think both are hugely impactful on the way that development processes run.
Yeah.
So when we talk about the QA side of things, that's mostly about cost savings or de-risking.
Yeah.
But the value of de-risking is not insignificant, of course. When we talk about like actually doing the player-facing content that is based on the same integrations, then we start doing a massive value add, because what happens there is that we talked about how quality is king in the games industry, right? And
Mm,
that's exactly what these kinds of bots will give you. They can verify the quality of your content, so they can make sure you know how your levels work. But they can also become content that you play against as you onboard onto the game. So for all games really, and in particular for multiplayer games, the one of the major determinants of whether you decide to stay in the game and keep playing the game over long term, one of the main
yeah.
determinants of retention is the first time user experience. And it's a
Mm,
very tricky and complicated thing to get right, because a player comes in, you don't know anything about their prior experiences or skill level, right? And now you have maybe 30 minutes to make sure that they understand what the game is about. They get set up. If it's a multiplayer game, they need to have someone to play against, and that person needs to be on their level, right?
yeah.
Because it's no fun to learn chess if you go down to one of the chess sharks in the park and you get wiped out like 10 times in a row. You don't
Mhm.
learn a lot from that, right? Then you probably don't want to pick up the game of chess. But if you have sort of like a nice learning curve, that's how we get you on board, and it's the same for any video game, right? You need to come in and have a good experience as you ease into and learn what the game is about. And that's the other side where AI can help you, because you can get an AI that has the right complexity for your skill level that adapts to your play.
Mhm. And so for the latter part, where once you're in the game, you want bots that learn how to play the game like humans and everything. I see the machine learning there. For the first part, for the QA, right? It's basically programming a bot to click and do all the different moves and everything that the game has to offer. How does machine learning fit into that problem? What's machine learning doing there as a
Yeah,
tool?
sure. Instead of you're actually right. Normally, like if you do these like automated script-based tests,
Yeah.
you'd have to program every click and set every case up, right? But the problem is, a game changes on a daily basis. So now you just gave yourself a new maintenance task. Because if you're developing the game, you're making new additions, you're changing the code, so your tests might be invalidated quite quickly, right? What we offer here that's novel and what machine learning adds is that you don't actually need to set up a rule for every different occurrence. That will
Okay.
be found automatically from the AI. So it takes the whole middle part of defining all the rules gets taken away. And what you have instead is like you just define what can the player do and what should I keep an eye on in the game. And then the AI fills out all the blanks there.
Interesting. What kind of, I'm curious, what kind of models are, or what family of models are you using for this purpose?
Yeah, so we usually start out with like the most sort of like fundamental method we use is essentially an online learning and search method that uses a quality diversity assessment algorithm. But what that means in plain English essentially is that the bot, the AI, the algorithm has a way of understanding what part of the game am I in, and then
Okay.
it will step through every part of the game and remember that it has seen it. And that can mean going to a part of the game, but it can also, it knows, for instance, if a door is open or if a door is closed. It knows if it's like in the western part or the eastern part. And so it will methodically go through all the different configurations of the game that it knows about. And because it uses an intelligent search algorithm and it has a memory of where it's gone before, it can online figure out, where am I going to learn the most about this piece of software? Where am I going to learn the most about the game? And then that generates the report. Now, what that
Interesting.
also generates, yeah, yeah, yeah. So that's the first step. And now the second step is that now the AI has seen like most of the game states, right? It's been
Yeah.
through most of the game, and
Hmm.
we've generated a data set of all these different states.
Yeah.
So now we actually have a library that we can go and learn from if we want to see specific sequences of states, right? Because now we've understood all the different ways that the game could be configured. It's a reduced version, of course, because most games are so infinitely complex, right? So you choose
Hmm.
like a complexity level, but now
Yeah.
that you have a data set, we can start learning more advanced behaviors from that. And then if we start getting human examples in there as well, we can start gaining human-like behavior. So once we're done with like the exploration part, we can then start imitating things that we've seen humans do inside of the same game environment.
I see. So is that like, and I'm gonna, get into a little more technical detail here. Is that more like you train a policy network or a value network or something like that? So you train models to learn the different states. That's number one. So it's a search. It's like a graph search, kind of like a graph exploration, you can call it, right?
Yep.
That's
Yep.
the
Yep.
basic one. And then you learn on the different states, right? And you learn on the behave all the actions that lead you to certain states, right? So you kind of training a policy network where for a given state, you know what actions to take in a way.
That's
Is
that's
that right?
exactly right. Once we step out of exploration and we step over into imitation, then we're training like these policies, and so then we're over in sort of like deep learning and neural networks. So, but
I see
but
what you
but
mean.
we combine the two things basically, right? And from the engineering side of things, we're leveraging the same interface into the game. So once you have like the right hooks in the game, you can sort of like swap out your gallery of AI methods on the back end, right? And choose
Mm,
whatever is the right fit for the task at hand.
I see. So the QA part, it still feels like it's not like a lot of heavy machine learning. It's still more automated. That's the feeling I'm getting.
It's online learning is the way to
Mm,
think about it. So you could call it maybe more classic AI, but it is actually learning like while it's running through the simulation, right? And that's then generates the basis for imitation learning and sometimes reinforcement learning on top of that.
I see what you mean. I see what you mean. That makes sense. And so, and you have the different, these different products, right? It's test and then create and then play. So they kind of fit into the three different ones where, which we just talked about, right? So let's move on to the next section in a way. Like, how did your team or how did your product evolve since the beginning?
Mhm. Yeah, I think. Well, I don't know if we're an atypical startup. Maybe we're not. We're sort of like I would call us a mixed game industry and research spinout.
Hmm.
So the people behind Model AI, we've been working together since I think the earliest relationship goes back to like 2007, where we started working together and building games together. And then we've sort of like picked up more people on the founding team on the way through like over the course of like 10 to 15 years, until in 2018 we decided to start Model AI together. And so our backgrounds are in game development and in AI and machine learning research. We're six people behind the company altogether.
Mm-hmm.
And we've been sort of like working together both in the games industry and then, over in research. I myself have a mixed background. I've shipped games and run game studios, but I also have a PhD in AI and machine learning for games. So we sort of like put that together, and we looked at the market and the technology in 2018, and we said, okay, we actually think that now is the time to take all of these methods that have been developed over in the over on the research side of things. You could see that deep learning had been coming into its own since, say, I don't know, 2014 is when it really started taking off, right? And we were seeing sort of like this openness towards using these methods over in the games industry. And so that's why we decided to start the company in 2018. So we have a founding team of four of us have been professors before and still are in research labs around the world: Copenhagen, Malta, New York University. And then three of us also have a background in game studios building games.
Wow, interesting. And so you directly started with attacking the problem in the way that we are talking about right now, or did you have to pivot the strategy or something like that?
I think we've been the foundations were already set in some of
Mm,
the work that we've been doing in academia, and we knew the methods, of course, so we knew the technology well.
yeah.
Then a lot of the work that we did early on was sort of like in verifying market and user needs, and making sure that the game developers actually wanted to use this, and also understanding the way that they wanted to use it, because like essentially game development is a creative process, right? And
Yeah.
it's very hands on. Everyone is so you need to shape the tools and the methods that you deliver. You need to package them in a format that is actually acceptable to the ongoing sort of like ways of running productions at the moment. And I think that's where we spent quite a bit of our early time figuring out how to package this and make it bring it all the way up to the front lines of game development.
Yes. And you know, as you're building an ML product and you're building kind of an online ML product, right, for all these different games, what have been the main challenges in building a reinforcement learning product, to be more specific, that are not very intuitive or obvious to typical game developers or software developers in general?
Yeah. I think you need to figure out a way of again sort of like packaging what the AI does in the right way. Either that can be through like an API that the developer interacts with, and they can just send their stuff through the API and get results back. That's wonderful, right? Then
Hmm.
they don't have to care about that part.
Yeah.
Or for some of the other products, for the QA part, for instance, we built it around a plugin that you can put inside of your game.
Mm.
So it's if you're using a modern game engine like Unreal Engine or Unity, you download our plugin and it adds onto the game engine inside of your game, and
Mm.
then that's what brings the functionality, right? So we actually abstract away the necessity for understanding machine learning or reinforcement learning or any of this, like, because that's actually not the concern of the game developer, right? You just
Mm.
package it in a format where it can be used in where it fits into their daily work.
Mm. And from your side, of course, building a machine learning product is itself like an iterative, like internal research department in its own way, right? So that's definitely like the product development cycles are kind of different, where you're actually trying out a lot of things, and then when you shift that to, okay, now we're putting reinforcement learning. I mean, very few companies right now are using reinforcement learning in a real product, right? And by the way, for any non-technical people listening to this, I'm going to link to an explaining article about reinforcement learning for games that you can read to get more familiar. But what have you learned in sense of, like, is there something were there some challenges that you faced when you realized that, okay, for building a reinforcement learning product, it's kind of even more different or difficult in a way compared to typical supervised machine learning products, where you have to collect the data and then you test different models and different algorithms for training and stuff?
Yeah, I mean, yeah, that's a great question. I mean, on one hand, the more you can, the more you can generalize and simplify what you do for each game, the easier it's going to be to get that working for the titles that you take in.
Mm,
So that's also why we started with the very broad sort of like the QA and the testing that we talked about, right?
yeah.
And then as you start getting more specific and you start wanting more advanced behavior inside of the game, I think what we've learned there is that you should be smart about which genres you start with. or what types of problems you start with, right?
I
We
see.
don't support all games, and there's a good reason for all types of games, and there's a good reason for that. We have found we decided to start in the part of the industry where both machine learning is a good fit and the problems seem tractable, and there's a large market opportunity. So the game genres that we've been focusing on first are the ones that have many games that make a lot of revenue and where machine learning works well.
Mm-hmm.
And then the final thing that you'll run into when you're using any kind of like both, well, in particular reinforcement learning for these kinds of games, is that game engines are they're big pieces of software and they don't necessarily run super fast. So you have to be smart about your training process. Like you wouldn't want to train a reinforcement learning agent from scratch necessarily in a big video game with complex behavior. You kind of want to start from some observations and maybe some offline learning and things like that. Because game engines are, they're big beasts. They have like a physics engine, and if you're doing
Yeah.
rendering as well, right? So you need to be really smart about sort of like training time and how many episodes and things like that you need.
Mm-hmm. Yeah, for those not familiar, I recall reading about when OpenAI trained their agents to play Dota. Although they were using directly like some image recognition and whatnot, so it's like their pipeline was even longer. But I
Mm.
remember they spent like millions of dollars to train the model.
Yeah.
Just on training costs, not even the development and everything, just on training for the hardware and everything. They had to spend millions of dollars just to keep the machine running. It's definitely a non-trivial cost too. It's not like, oh, like everything on the cloud is cheap, so just plug it in and into AWS and you train whatever, you have infinite compute.
Exactly, and then you're like, I'm going maybe if so that's interesting from a research and development perspective, right? But if you're a game developer, maybe you just want to spend like $2 million on some AI programmers that script everything out. So that's not necessarily a good value proposition to the games industry. The way that we've sort of like approached that is that we do hybrid and hierarchical models. So we try to and break down the different behaviors into smaller neural nets that sort of like deal with different parts of the situations, and that makes it a lot less expensive, and you can also do it with less data typically, but of course it's a little more hands-on, right? But you can trade a lot of that. You trade some generality for injecting expert knowledge, and that's sort of like how we've approached it. And then we're back in the genre discussion where you say like, okay, you can do that for certain kinds of games that are very similar. Maybe it's actually okay to do this. If you're a very hardcore AI machine learning person, you're like, oh no, that's cheating because we're not learning the behavior from scratch.
Mm-hmm.
And I'm like, yes, but it's very efficient. So as long as the games are very similar, I think it's fine. Then you can reuse both some of the models, but also the expert knowledge like within that genre, right? Over time, we like our strategy actually is to over time then generalize from there, and then start covering genres with more and more general models until we sort of like have you could say like foundation models for different types of games. That's the end goal that we want to achieve with the AI engine.
And so, just for more clarity, you said that you chose a genre of game or a segment of the market that would make it easier for the reinforcement learning models to be applied and to be for the whole system to work really well for a certain niche, right? Because you can't be everything to everybody. So give some examples of these type of games which are both easy for a machine from a machine learning standpoint and also profitable and also growing really fast.
Well, I can just go back to the kinds of games that we serve, right?
Yeah.
In the casual space, puzzle games is something turn-based puzzle games, or some of them are semi-real time. So anything like Candy Crush, match-3 games, like that comes up out of some of these like large casual studios. I think they're a great match for machine learning-based agents. And what we do there is actually we use the bots to play the levels and assess the difficulty for the developers, so they can put in a level, and then they'll understand like how difficult it is and where it fits in the player's journey, so to speak. Actually, we also generate levels for people over in the casual space sometimes. So we actually have a generator, and then the bots will play the generated levels, and then you have an infinite amount of evaluated levels that go together. But I think that space is great for machine learning, and then any kind of continuous space real-time control action game where you have a single player character that represents you. So everything from again, we talked about Fortnite, or Minecraft is perhaps a little open-ended, but
Yeah.
but any of these like action FPS or third-person games are typically good matches for this kind of tech at the moment. I think where things get a little more complicated and where that's places where we're not at the moment is in strategy games. We
Yeah.
don't do a lot of that at the moment, or narrative games, or sort of like very sort of like open-ended multiplayer role-playing games where most of the games are about social interaction. Those are much more challenging for some of these methods, right?
Yeah, like point and click games like Age of Empires, or what is like a game like GTA would be fall into your genre in a way. That means.
Yeah, yeah, absolutely. Something like GTA is something that we'd look at, right? I would say, some of our team members have experience in building bots for, versions of StarCraft and things like that. So it's not
Mm,
completely out of our wheelhouse, but it's just not. We don't see,
yeah.
the intersection of tech and commercial opportunity for an outside vendor is not quite there for us at the moment.
Awesome, awesome. Well, Christopher, thank you so much for coming on the podcast and sharing your wisdom with all of us. This is stuff that we don't get to hear about very often in content, business content online, and so glad we had this conversation and can document this knowledge for everybody to see.
Come on, real pleasure. Thank you for having me.
Awesome.